Okay, you should have already put all these vocabulary words in your notebook. Just really quickly, I want to talk about this. What does the word initial mean? Beginning. Does everybody understand that? And what does the word terminal mean? Ending, okay. Initiation, you guys know that word? You bring someone new into a club or something like that. You do, okay. So initial means beginning, okay. And then terminal means end, like the end of when you're getting on an airplane at an airport, you get to the end of the airport. It's called a terminal. Okay, to terminate means to end something. Okay, so when we do that, when we have that, we have an initial side and an ending side. Now, by the way, I did this arrow right here. Which side would be the terminal side? The top would be, because it's where it ends. See, I start right here and I end right here. So the bottom is initial, and the top. So this would be the initial side, and this would be the terminal side. Okay. Now, can you turn an angle in the other direction? Yeah. Okay. So we always kind of think of it as starting right here, and we just turn it like that. Okay. So, and then what's this point right here called? Vertex. You should know that from geometry. Okay. Terminal, initial, or new. That's not something we use in geometry, but it is what it is words that we use in trigonometry. Okay. Which way does a positive angle turn? Okay, counterclockwise. So it turns in this direction right here, right? Okay, and the negative angle goes in which direction? Clockwise. So it turns in this direction right here, right? And an angle in standard position. This is really important to understand trigonometry. Where is the initial side? Well, where is an angle when it's in standard position? Where is it, Brock? Okay, so where's the vertex located? At the origin. And where's the initial side located? Okay, yeah, along the positive x-axis. And then the terminal side can be anywhere, right? Depends on which way we turn it, whether it's positive or negative. If I was to turn a positive angle maybe this far, and so my terminal side ended right there, okay, that is an angle in standard position. So just know it, the vertex is at the origin. The initial side is on the positive x-axis anytime you have an angle in standard position. Almost every time we work with angles in trigonometry to begin with, you're going to be working with an angle in standard position. So you need to know that. On your next test, I will say, given an angle in standard position, find this, okay? So if you don't understand what standard position is, you're going to be lost right there. All right, next. Okay, degree, minutes, and seconds. How many degrees in a full turn? Okay, you guys all know that. Now, let me give you an example. This is 27 degrees, 38 minutes, 42 seconds. Okay, that's an example of degrees, minutes, seconds. That is a little bit different than what we call decimal degrees. Okay, we could write degrees as a decimal. Why would we have degrees, minutes, seconds? What's the purpose of it, do you think? Well, they're not really coordinates. It's still a measure of an angle. We're still measuring an angle, but why would we have minutes and seconds? What would that help us with? Let's say you're going to shoot a missile. You're in the military, you're going to shoot a missile, and your target's 5 miles away. Okay? And you shoot it at 38 degrees. Is that going to be different than, 27 degrees. Is that going to be different than 27 degrees, 38 minutes, 42 seconds? Is that different angle? Are you going to hit a different place? If I aimed a missile at 27 degrees, is that going to be different, Rhett, than 27 degrees, 38 minutes, 42 seconds? It's going to be off a little bit. By the time you go 5 miles, it's pretty close to the same angle, but by the time you get there, you might be 100 feet off, right? Is that going to make a difference? Okay, so it's just the purpose of degrees, minutes, seconds is to be more precise. And so you know, there are 60 minutes in a degree, right? Did you write that down? 60 minutes per degree? We do, and we're going to show you that in just a second. And they use both. Okay, how about seconds? How many seconds? There's 60 seconds in what? In a minute. So how many How many seconds are in a degree? 60 times 60, which is 3,600. Okay? So there's 3,600 seconds in a degree. So you can see with seconds, you're being a lot more precise because there's 3,600 of them in a 1 degree. So you're being very precise. Okay? All right, now I'll show you in just a second how we're going to change degrees, minutes, seconds to decimal degrees. Okay, longitude lines and latitude lines. Which way do longitude lines go? Up and down. And latitude lines go parallel to the equator, right? So if you wanted to use the same definition, longitude lines are perpendicular to the equator, okay? So you're going to need that for your assignment today. Okay, going on to the next slide right here. We're going to learn how to change decimal degrees to degrees, minutes, seconds, and vice versa, okay? So, why, Cassie just asked, why do they have, why don't they use decimal degrees? Well, sometimes they do. Sometimes they use degrees, minutes, seconds. Why don't they just use one way? I don't know. But someone came up with that a long time ago, and that's what we use, okay? So 15.735 degrees to degrees, minutes, seconds. Well, if there are 60 minutes in a degree, right? 60 minutes in a degree. I'm going to take that decimal and I'm going to times it by, everybody take out your calculator. McKay, wake up. You got to do this. Okay, take out your calculator. I want everybody to take 0.735 and times it by 60. So in other words, you're going to take the decimal and times it by 60. What do you get? Okay, so the part that's not behind that's not the decimal is going to be the minutes. So 44. Now take that 0.1 and times that by 60 and what are you going to get? You're going to get 6. So there's 6 seconds. So 15.735 degrees is the same thing as 15 degrees, 44 minutes, and 6 seconds. Got it? Everybody, do this one right here. Okay? 82.587 degrees. I want you to change it to degrees, minutes, seconds. Degrees, minutes, seconds. Okay, punch it in there. I want everybody doing it. You got it? Okay, so what did you guys get on this one? So 82 degrees, 35 minutes, 13.2 seconds. Okay, so if you have a decimal on the end of the seconds, you just leave it with the seconds, okay? Raise your hand if you know how to do this. Raise your hand if you're not sure. Okay, one more. Okay, okay, everybody that didn't get it, do this right now. Take 0.587 and times it by 60. 0.587 times by 60. You should have got 35 point something, right? 35.22? Okay, so you got 35 minutes. Then you take the 0.22 and times it by 60, and you should get 13.2. Got it? Okay. Everybody do this one right here. 183 degrees, or 83.019 degrees. Change that to degrees, minutes, seconds. Okay, so we know it's 183 degrees. How many minutes? 1 minute? 8.4 seconds. Anybody not sure how we got that? Okay, now, everybody take your calculator and type in, let's do this one right here, 15.735. Type it in. Just put 15.735. Then go to the apps button, except for go to the angle above it. So how do you get that? Second, an apps button. second and apps button. Joseph, come over here and sit right there because we're doing a little work together. Okay, notice that number 4 says DMS. DMS stands for degrees, minutes, seconds. DMS stands for degrees, minutes, seconds. Hit that button. Hit enter. It should give you this right here, 15 degrees, 44 minutes, 6 seconds. Okay? Okay, you guys ready this time? Okay, did you type in 15.735? Okay, go to the angle menu. The angle menu on your calculator is above the apps. So you have to hit second and apps. And number 4 is DMS. And hit enter. That's the same one we got it, doing it the other way. Okay? All right. All right, so we know how to do that now. So the reason I showed you the other way first is I want you to understand how it's done, what the calculator is actually computing. Okay, now go to this one right here. We're going to do it opposite. We're going to change 39 degrees, 5 minutes, 34 seconds to decimal degrees. So to do that, we're going to take 39 and we're going to add 5 over what, do you think? 5 divided by what? 60. That's right. Because there's 60 minutes in a degree, right? I mean, yeah, 60 minutes in a degree. Plus what? 34 over what? Not 60. No. But we're, huh? 3,600. Why 3,600? In a degree, yeah. There's 3,600, and we're changing this to degrees, not minutes. If I was changing that 34 seconds to minutes, then I would divide it by 60. But it's, yeah, so everybody type that in. 39 plus 5 over 60 plus 34 over 3,600. And that should give you your decimal degrees, which is 39 point what? 092? 093? Did you round it up or something? Okay. 39.093. Yeah, round these to 3 decimal places. 0.093. Okay. Everybody change this one. 89.728. 89.728 degrees. Change that to degrees. I'm sorry. Wrong problem. 89 degrees. 28 minutes. 56 seconds. Change that to the decimal degrees. 89.482. Okay, any questions on how to change those back and forth? You guys got to know how to do this. Changing those back and forth. It's real easy, okay? All right. Okay, now, really quickly right here, we got 2 more words to define. Quadrantal angles. Some of you guys saw this in your book already. I could have had to do this. But quadrantal angles, go to your book right there. What is the definition of quadrantal angles? The terminal side of it. Okay. There are, the reason quad, what does the word quad mean, you guys? 4. There are 4 quadrantal angles in between 0 and 360. Okay? Notice that it said it's an angle in standard position. So you have an initial side. And where does the terminal side lay? Where does it say? On an axis, right? On an axis. So here's the first one. A 90-degree angle, you guys, is a quadrantal angle, okay? A 90-degree angle is the first quadrantal angle. What do you think the second one is? 180. If you turn it around 180 degrees, 180 degrees is the second quadrantal angle. What do you think the third one is? 270. Okay, if you turn it 90 degrees 3 times, you get 270 degrees, right? Every time your terminal side ends on an axis, that's called a quadrantal angle. And the last one? Yeah, if you go all the way around 360 degrees, your terminal side and your initial side, the initial side and terminal side are both along the positive x-axis. 360 degrees is the last quadrantal angle. There are other quadrantal angles because you can keep going around. That is one thing that's different about trigonometry than geometry. In trigonometry, we study rotation, not just an angle measure, but the rotation. And so we can have any degree we want. We can have positive degrees, we can have negative degrees, we can go to 1,000,000 degrees. Okay? That's just whatever 360 into 1,000,000 is, that's how many rotations you're going to have. Okay? So that's what a quadrantal angle is. Okay, a coterminal angle. Let me describe a coterminal angle. Okay? Mallory, read us a definition of a coterminal angle.
Two angles in standard position are called coterminal angles if they have the same terminal side.
Okay, two angles are coterminal if they have the same terminal side. Okay, there's one angle in standard position. Okay, here's its terminal side right here. This one up here is its terminal side. Okay, how could I get another angle? See, this one's right here. Turns it this much right here. I'm going to draw it in blue. How could I get another angle that's coterminal to this? In other words, its initial side is going to start the same place, and its terminal side is going to end the same place, but it's a different angle. How could I do that? Okay, that's one way. I could go all the way around right here. Okay, I could go that way, and it ends the same place. So it has the same terminal side, right? Think about co. What does co mean? Together, right? Okay, the same. It means the same. Terminal means the terminal side of the angle, right? So the same terminal side. So this one, let's say this angle right here was 60 degrees. If I went this way, around this way, it's a negative angle. How many degrees do you think that is? Huh? Negative 300 degrees, right? Okay, because you went around the other way, negative 300 degrees, and you ended the same place. Is there another way I can get a coterminal angle? And go in the positive direction. 420. That's right. Okay, if I did this right here, if I started right here on the initial side, and I went around and ended right here, 420 degrees. So I went clear around. So how do you find a coterminal angle? I'm going to check right here. Everybody's got 45 degrees. Find me an angle that's coterminal 45 degrees. Use your calculator if you need to. Okay? When you got it, raise your hand. Find an angle that is coterminal of 45 degrees. Okay, what do you think? Who's got one? Besides Cassidy. Is Cassidy the only one that understands this? Okay. Aaron? Anybody else? By the way, we have two new students in this class, Aaron and Jennifer. Were you in Mrs. Kidd's class before? Jenny was in my other class, so they just transferred in here. They probably had to change your schedules. Is that what you had to do? Okay, so they're in our class now. All right, so 45 degrees. Okay, what is it, Aaron? Negative 315. How did you get that? Is that what you said it was? Yeah, he just subtracted 360. What did you get, Cassidy? He got 405, and so all you did is added 360, right? 405 degrees. So 405 and negative 315 are both coterminal with 45 degrees. Rhett, can you name me another one, or how would I get another one? Rhett, put 45 degrees in your, just put 45 in your calculator. Add 360, what do you get? 405, that's how we got that. Now go plus 360. 765. So plus 360 will give me 765. There's another one, you guys. Okay? Drake, give me another one. Vincent. What would I do? I'm coming back to you. Jack, give me another one. Negative 675. What did you do to get that? From 315? Okay. What is it again? Negative 675. Okay. Kristen, give me another one. You guys all get one. I'm going to ask someone else one. Huh? Negative 10 what? 1035. Okay. Give me another one, Vincent. I shouldn't put equals right here. I should put arrows. Sorry. Huh? 1125? So you added 360 to 765, right? All you have to do is add 360, subtract 360. Okay, everybody, I'm going to give you a minute. I want you to come up with several angles that are coterminal to 225, positive and negative. I'm going to ask some of you guys, okay, in just a second. You already got some? Basketball? What time you guys got to go? Right now? Okay. Yeah, there is an assignment. Okay. I'm going to flip to the assignment for him. In fact, everybody, write down the assignment right now. Lesson 5-1, page 281, 19 through 61 odds. Okay. All right, go back to this one right here. Okay, 225 degrees. What's an angle coterminal with 225 degrees? Say that again, Alex. 185? 585. 945? Okay, give me, Vincent, give me a negative one. Negative 135. Does everybody agree with that? Okay, give me another one. McKay.
It's going to be like 135.
I'm coming back to you. Joseph, give me another one. Negative what? $495? Okay. Just add 360 or subtract 360.
1665.
Huh? 1665 is another one. Okay, going on to the next one. Okay. This is one of the things I'm going to ask you to do on your test. It says if each angle is in standard position, determine a coterminal angle that is between 0 and 360 for this. Okay, go. When you got it, raise your hand. Alex has got it. Anybody else? Courtney? Okay. Courtney, tell me what you have. 55. Alex, what do you have? 55. I believe that is correct. How did you do that? Minus 360 twice, right? Minus 360, and you got what? 55 degrees. Okay? So if you keep minusing 360 until you get an angle between 0 and 360. Now, on your test, I'm going to ask the question a little bit different. I'm going to say, find a least positive angle coterminal to 775. A least positive. A least means smallest, but it has to be positive number. So in other words, it means it has to be a number between 0 and 360. Got it? Okay. Find one for negative 1297. When you got it, raise your hand. No, not yet. How many got 145 since McKay said? 143, does everybody agree with that? 143? Should have just added 360 till you got a number between 0 and 360, right? So 143 for that one. Okay. All right. Okay. Define reference angle. Okay, I want you to go to your book. I want you to read the definition first, and then I'm going to tell you what it is. Off when I was doing that. Just showed these guys. If you're at home, look this up in your book. I forgot to turn it on. Okay. Reference angle. So find A and B. Find the measure of the reference angle for 120 degree angle. When you got A, raise your hand. Okay. Alex, what do you think it is? What do you guys think? Do you guys agree with him or disagree? Yeah, agree, because reference angle is always between, so 120 degrees is about right here somewhere. Actually, it's up here more. Sorry. Let me rewrite that. Okay, 120 degrees is the angle that's about right up here. Okay, it's 120 degrees, and it's in the second quadrant, and so the reference angle would be between, it's always between the terminal side and the x-axis, the acute angle between the terminal side and the x-axis. So it would be the measure of that angle, which is 60 degrees. You always, reference angles are always positive angles, okay? You're never going to name it as a negative angle. Okay, find negative 135. When you've got that one, you've got the reference angle for that one, raise your hand. Okay, Joseph. Is it 45? What do you guys think? Yeah, it is, because negative 135 would be the angle right here, right? Down in the third quadrant, and it's on a 45 degree angle, so it'd be another 45 degrees to get it up to there. So remember, reference angle is always between the terminal side, the acute angle between the terminal side and the x-axis. And so that would be 45 degrees would be the answer to that one.
So I go for the second one, would it be negative 70 degrees?
This one?
Yeah, would it
No,
be
that's
70?
positive 70. A reference angle is always positive. Okay. And then you guys all wrote down your assignment already, right? Okay. You still got 13 minutes left in class or so, 15, because I think they've got the school clocks a little bit late. Okay.